The real number system is important to understand in math. The real number system includes numbers that can be shown on a number line. Here are some examples on this number line: -4, -1.5, 0, 1/2, pi, 8. All are examples of real numbers. The real number system is made up of both rational and irrational numbers. Let's talk about the difference. Rational numbers can be expressed as a ratio or as a fraction. So this would include fractions, decimals that are repeating or terminating. Terminating means that they end. Also includes integers, both positive and negative numbers. And also perfect squares are included in rational numbers. Irrational numbers cannot be written as a fraction. Therefore, these would be all non-terminating and non-repeating decimals. Let's look at some examples of real numbers and see what categories these numbers below would fall into. So let's look at an example of a natural number. Okay, 9 would be a natural number. Natural numbers are 1, 2, 3, 4, 5, and so on, are regular counting numbers. Okay, included in whole numbers would be the example of 0. 0, 1, 2, 3, 4, 5, 6, etc. would be in the set of whole numbers. Integers includes whole numbers and their opposites and 0. So a number like -5 would be considered an integer. Then we have some examples of rational numbers that do not fall into the category of integers, whole numbers, or natural numbers. For instance, 7.363636. You can see that this is a repeating decimal, therefore it would be a rational number. 11.23, or 11 23/100 would be a rational number because it's a terminating decimal. -2/3 would be another example of a rational number. You can see it can be written as a fraction. Okay, the remaining numbers are all examples of irrational numbers. These are numbers that, when written as a decimal, would not terminate and would not repeat. Okay, next we're just going to give some examples of these different types of decimals. Terminating decimals. Okay, looking below, a couple examples of terminating decimals would be 1.25. Okay, we can see that decimal ends. Also, any whole number like 4 would be considered a terminating decimal. We can think of it as 4.0. Another terminating decimal, 1/5, can be written as a decimal, 0.2. Okay, some examples of non-terminating decimals. These are decimals that go on and on, non-terminating. Okay, this would be an example of a non-terminating decimal. Okay, another example of a non-terminating decimal would be this example. Okay, repeating decimals are decimals that repeat. They go on and on, but they repeat. So this would be an example of a repeating decimal. You can see that the 2-3 is repeating. A non-repeating decimal would be something like this. Okay. Also a non-repeating decimal. We could also say that 1/5 is a non-repeating decimal. It's just equal to 0.2. An example of a non-repeating, non-terminating decimal would be something like pi. Pi goes on forever, but it does not repeat at all in any way. So it's a non-terminating, non-repeating decimal. This would be another example of a non-repeating, non-terminating decimal. Okay, let's look and see if we can identify the rational numbers. Okay, if we look at the first one, 2 and 5/8. Okay, that would be considered a rational number. You can see it can be written as a fraction. Also, it's equivalent to the decimal 2.625, which is a terminating decimal. Okay, 0.7 would also be a rational number. It's a terminating decimal. The square root of 64, which is equivalent to 8, which is a whole number, would be a rational number. 0.3 repeating is a rational number because it's a repeating decimal. -9 is an integer, therefore it would also fit into the category of rational numbers. 12.03 is terminating, therefore it would be a rational number. And 2 2/7 also written as a fraction, and if we did change it to a decimal, we would see it becomes a repeating decimal. Therefore, the two irrational numbers here would be the square root of 3. Okay, you can see the square root of 3 is a non-repeating, non-terminating decimal. Therefore, we would say the square root of 3 is irrational. Also, pi would be an example of an irrational number. Okay, at this point in the video, I would like you to stop the video and attempt to decide whether these fractions, square roots, decide whether these numbers are rational or irrational. And try to be able to explain why you thought they were rational or irrational. Okay, now that you have tried these problems, let's take a look. 3/7. This would be considered a rational number. It can be written as a fraction. The square root of 16, since that's equivalent to 4, okay, that would be also considered a rational number. 4 is a whole number. 2/11, again, it's in that fraction form, or you can think of it as a ratio of two integers. That's considered rational. And the square root of 6, if we would think of this as a decimal, this would be our decimal for the square root of 6. We can see this decimal does not repeat and it does not terminate. Therefore, the square root of 6 would be irrational. Okay, this is another time in the video when you can stop the video and see if you can order these decimals from least to greatest. A hint is to write each decimal out to 4 places. That might help you. Okay, now that you've tried this problem, let's take a look. If we write each decimal out to 4 places, we would find that 0.3 with the 4 repeating would be equivalent to 4 places to 0.3444. 0.34 with a 34 repeating would be the same as 0.3434. 0.342 repeating would be 0.3423, and 0.342 would be 0.3420. Now that all these decimals are out to 4 places, we are able to compare them and order them from least to greatest. If we take a look, that would put them in this order. So 0.342 would be our smallest value, then 0.342 repeating, then 0.34 repeating, and then 0.3 with the 4 repeating. Okay, last, let's take a look at comparing numbers. So if we take a look at 3 and the square root of 7, let's look at these on a number line. If we take the number 3 and put it on a number line here, plot it, okay, we'll take a look at the square root of 7. The square root of 7 as a decimal is approximately 2.65. So the square root of 7 would go right about here on the number line. Okay. Therefore, we can see that 3 is greater than the square root of 7. Let's take a look at the next one. 4 and the square root of 16. Let's plot these. 4 on a number line. Square root of 16 is actually equivalent to 4, so they would end up plotting at the same spot. Okay, therefore we would find that 4 is equal to the square root of 16. Okay, let's see if we can get this one a little bit neater here. And we found 3 is greater than the square root of 7. Okay, that reviews our real number system.